Problem number 5. A unicyclist goes around a circular track at radius 30 meters at an amazingly fast constant speed of 10 meters per second. At what angle to the left or right of vertical must the unicyclist lean to avoid falling? Assume that the height of the unicyclist is much smaller than the radius of the track. Solution. Let's draw a free-body diagram. For this problem, it's better to use a rotational frame of reference in which this unicyclist is stationary. So we just need to solve the problem for static equilibrium. In this rotational frame of reference, we have additional frictional force, which is equal to mv squared over r. On this diagram we have 4 forces applied to unicyclist. First force is mg, that's a gravity force applied to the center of gravity of unicyclist. Second force is normal force, which is equal mg because of equilibrium in vertical direction. Force of friction must equalize this frictional force ma, that will be equilibrium in horizontal direction. And also we have rotational equilibrium around point of contact. In this point, force F and force N have zero torque, so it means that we don't need to count them. And we have only force mg and ma, which create opposite torques. Let's write equations. Force of friction F equal ma equal mv squared over r. And finally we have tangent theta, angle between vertical and the unicyclist, and that's equal to v squared over gr, which is 1/3. And the correct answer for this angle is C, 18.4 degrees. Problem number 6. A cubical box of mass 10 kg with edge length 5 meters is free to move on a frictionless horizontal surface. Inside is a small box of mass 2 kg, which moves without friction inside the box. At time t equals 0, the block is moving with a velocity 5 meters per second directly towards one of the faces of the box, while the box is initially at rest. The coefficient of restitution for any collision between the block and box is 90%, meaning that the relative speed between the box and the block immediately after a collision is 90% of the relative speed between the box and the block immediately before the collision. After 1 minute, the block is at displacement x from the original position. Which of the following is closest to x? Solution. Here we can use momentum conservation because we have no friction. It means that we can count what is the speed of center of mass of this system. This is the formula for momentum conservation, and the speed of center of mass equal this expression. Now we can count what is the distance of center of mass. Distance covered by center of mass equal 50 meters, and we see that because size of this cubical box is just 5 meters, it means that our box not further than 2.5 meters from the position of center of mass. And if we look at the answers, we have closest position is B, 50 meters. Problem number 7. A 1 meter long stick with a uniform density is allowed to rotate about a point 30 centimeters from its end. The stick is perfectly balanced when 50 gram mass is placed on the stick 20 centimeters from the same end. What is the mass of the stick? Solution. Let's draw the picture for this case. Here we have stick with the length 1 meter and unknown mass. Here we have mass 50 gram placed 10 centimeters from the point of balance. And the center of gravity or center of mass of the stick is 20 centimeters from the point of balance. So here we have right equilibrium for torques. M big G L big equal M small G L small. And from here we can find what is mass of this stick. Finally, that will be 25 grams, which is answer C. Problem number 8. An object of mass M is hung on a vertical spring or spring constant K and is set into vertical oscillations. The period of this oscillation is T0. The spring is then cut in half and the same mass is attached, and the system is set up to oscillate on a frictionless inclined plane, making an angle theta to the horizontal. Determine the period of the oscillations on the inclined plane in terms of T0. Solution. We know that the period of oscillation for mass M on a spring with a constant K equal this expression. If we cut spring in half, we will increase spring constant twice. And if we put this system on incline, it will not affect period, it will just affect point of equilibrium. So it means that if we in this formula increase K twice, we decrease period by square root from 2, which is answer D. That's correct answer.